We'll start by taking a look at some example code. Our example code will be that of a shipping calculator. The idea here is that we have a customer who's maybe checking out on a website, and we need to calculate the cost of shipping their order to them. Now, that cost may vary depending on how the customer has chosen they want the package to arrive. The customer has the choice of choosing Federal Express or FedEx, UPS, or the United States Postal Service. And we're going to calculate a different cost depending on which carrier the customer's chosen during the checkout process. Okay, here we are in Visual Studio, and we're going to take a look at our sample implementation. We're going to drive our sample implementation through some unit tests that we've written over here. We could just as easily have used a command line utility. We could have created a command line exe to run our little app, but we've got some unit tests here. Now, the intent is that when we're shipping via UPS, then our particular order is going to cost $4.25. When we're shipping via the United States Postal Service, it'll be $3. And when we're shipping via FedEx, it'll be $5. That's what our tests are showing us. Now, we can break apart the functionality of our shipping cost calculator. Our shipping cost calculator is this little class here, and we're going to new it up, and then we're going to provide to it an order. We get an order from this little mother class. This is just a helper within our test project. There's no black magic here. We'll jump in and take a look. All we're doing is we're creating an order, and an order has a shipping method. So in this instance, our order actually knows how it wants to be shipped, and we have a destination address and an origin address. Okay, so back over in our test, we're going to pass that order to our calculator services calculate shipping cost method. From that, we'll get the cost of our order, and then we'll assert that our cost is correct. Now, before we go too much further, we'll just go ahead and run all of our tests, and they do in fact pass. So we know that our algorithm is correct. And maybe that's no problem. Let's go down into the calculate shipping cost and take a look at how this particular method's implemented. What we'll find is that the calculate shipping cost method takes an order as its input, and this is very common syntax that we might find in code. We are going to switch on the shipping method of the order. So how does the order want to be shipped? And that could be either FedEx, UPS, or United States Postal Service. And one thing about using this technique is that it's very possible that we're going to get a shipping method passed in on this order that we're not actually coding for. And so in that instance, we go ahead and throw a new unknown order shipping method exception. So we've had to account for that possibility. Down here in our methods that actually do the calculation, you may imagine that in a production system, rather than just having a single one-line return, after all, not everything is going to cost $3. We're going to go out, make some service calls. We're probably going to calculate some things like the weight of the items in the order. I don't know, there are a lot of things that can go into calculating the actual cost of shipping. So this would likely be a very large algorithm, as would the one for UPS. We have a different algorithm for UPS and finally another one for FedEx. For the purposes of our example, let's just work with these hard-coded numbers, realizing that we'd probably have a much more complex algorithm for deriving each shipping cost. Now, what are some problems that we can note about this type of implementation? First of all, our order actually has to know what type of shipping our customer preferred. That's arguably not appropriate for an order to even know what type of shipping the customer wanted. Depends on the data model and the domain that you might be using. But one thing we can see is that when we add a new shipping method. Let's say, for example, we want to ship with DHL and our company cuts a contract with DHL to do some shipping. We're going to have to open up this class and we're going to have to modify it. Now that sort of breaks the open close principle right away, because we're going to be modifying this calculate shipping cost method. The open close principle states that a class should be open for extension but closed for modification. And I would venture to say that adding another case statement here would be opening up this class for modification. And then finally, anytime we want to change any of these algorithms, we're going to need to open up this shipping cost calculator service class and ensure that our algorithm for, say, the postal service, if that's the one we're changing, doesn't impact the algorithm that we have for UPS and FedEx. We may very well have some shared state because of the mechanism we're using here. So there are some issues with this architecture, and it would be nice if we could calculate things independently of the shipping cost calculator service class. And that's where the strategy method comes in.